In this video, we're going to be explaining the following problem under quadratic equations and using a new technique called completing the square to solve and find the solutions to this equation easier. The problem says, find all solutions to the equation x squared minus 7x equals 30. Now, there are a variety of ways you could go about this problem at first glance. You could go ahead and get this into regular quadratic form, which is any equation of the form x squared plus or minus bx plus c equals 0. You could subtract the 30 from both sides until you get an equation equal to 0, and then you could use factoring to find the solutions or the roots of the equation. However, this technique could be quite cumbersome and take a long time, especially when factoring complex quadratics. So in this video, we're going to look at a different technique for solving an equation called completing the square. So basically what this technique does is it leverages kind of the mystery aspect of the constant term c in any quadratic equation. As a reminder, the constant term c, I'm just going to write out the form of a quadratic here, so it's easier to see. This is the form of a quadratic equation, and the c is this mystery term we're trying to find out when we complete the square. And it's called completing the square because we're trying to find the value of c that's going to be a perfect square. In this case, c is always going to be a perfect square that satisfies the equation for the constant value bx and x squared when we then factor it down to a binomial. So that's the main premise of completing the square. Now, to really get it and understand it in action, we're going to have to see it apply to a problem. So when we solve this question, we're going to use the completing the square technique to see how this works and see how it could speed up the process of factoring a quadratic. So right away, and in fact, for this technique completing the square, this form right here, x squared minus 7x equals 30, this is the exact form you want it in. It's already in the correct form. And this is because we don't have a constant term c on the left side. We only have our x squared minus 7x in this case. So that's a perfect setup for setting up a mystery box. So to start off, we want to put in a mystery box for the c constant term because we don't know what it is and we're trying to find that out. So we're just going to go ahead and write down, adding our box into this, x squared minus 7x plus the constant term c equals, we have to do this to both sides, 30 plus that same constant term c. So we've got a mystery value for the constant on both sides now. From here, we can leverage an important rule that you're going to need to know when using the completing the square technique. The rule states that the constant term c is always going to be, in parentheses, b over 2 squared. So the constant term is going to be b divided by 2, and then you take that entire fraction and you square it. So that's the rule there for the constant term c, and that's really going to help us solve this problem and figure out what number to put in those boxes. So we've got our mystery box set up right here. We now have all the information we need to put in values to those boxes because we have our b. Our b, get a different color here, our b is going to be our negative 7 right here. That's our value for b. That's the coefficient of x. So we can then apply our formula. We can use our b over 2 squared. It's going to be simply negative 7 over 2 squared. So then we can multiply that out. We wind up with always a positive number when squaring, unless we want imaginary numbers. We're not necessarily dealing with imaginary or complex numbers here. We only want the real ones. So we wind up with 49 over 4 as the expansion here. And that's what goes directly into these mystery boxes. 49 over 4 goes right in there. So now we can write our filled-in quadratic, getting x squared minus 7x plus 49 over 4 is equal to 30 plus 49 over 4 on both sides. All right, so we've got this completed quadratic now. We can then go ahead and simplify some like terms here. We've got our 30 plus 49 over 4. We find a common denominator, and we're just going to go ahead and write this out. If we simplify that right side, we get a 169 over 4. And this is going to be very important for later when we go through the process to remember this 169 over 4, because we're going to use that to find our final answers. So, from here, this is the next step of completing the square. We need to simplify down this left side into a binomial, which is basically any expression in parentheses then squared. So when you multiply it out, it has two terms. So we need to get this down to a binomial, and the way I like to go about thinking this is take a look at the constant c. It's our constant term here. All we have to do is, in parentheses, we're going to write over here x, and then plus, if we're going to make it minus if our coefficient of x is negative. In this case, it's going to be minus. We have x minus. If this were positive 7x, we would write a plus here, but it's not. It's negative, so we'd put a negative, a minus sign there. From there, all you have to do is just look at the constant term c and take essentially the square root of this. That's all you have to do. X minus or plus, depending on the parity of this coefficient here. And then, all you have to do there is take the square root of the constant term. So, the square root of 49 over 4 is 7 over 2. So, x minus 7 over 2. And that's going to be squared, because we basically simplify it down to a square of binomials. And this equals 169 over 4. Okay, from there, all we have to do is to take the square root of both sides. This is where our right side, 169 over 4, comes in handy. Because, you can see here, 169 is a perfect square. In fact, it's 13 squared, if you know what your squares are. So that's 13 squared is 169. And of course, square root of 4 is 2. So we wind up with 13 over 2. We also got to be careful here because we're dealing with square roots. And any square root could be either positive or negative. So, this could be plus or minus. That's a symbol for plus or minus 13 over 2. Okay, so we've got our simplified quadratic here. This is pretty simple from here. All we have to do is essentially simplify this equation, just like we did with any other equation. So we're going to have two values here. It's going to be a positive value and a negative value. Let's start with the positive value. So assume that 13 over 2 is positive. In this case, we have x equals 13 over 2 minus 7 over 2. And that means x is simply going to be, if we have positive 13 over 2, it's going to be plus, because we're adding it to both sides. It's going to be plus 13 over 2 plus 7 over 2, which is 20 over 2, which is 10. That's one solution right there. Now assume that 13 over 2 is negative. We'd have x equals negative 13 over 2 plus 7 over 2, which is equal to negative 6 over 2, which is equal to negative 3. That's our second and final value. So we have successfully found all solutions to this quadratic equation, 10 and negative 3. So that's how you would use the completing the square method to successfully solve and find solutions to a quadratic equation of this type. You could choose to do factoring on this. You could find the two numbers that multiply to 30 and then add to negative 7. You could do that way. That might take longer though, because then you'd have to use a significant amount of guess and check to get to your final answer. That's why, especially when you're dealing with more complex quadratic equations, long ones with large numbers like 5,000 and 3,000, stuff like that, you want to use the completing the square technique, because it overall just makes things a lot faster and easier to visualize and to get to your answer. Alright, that's pretty much it for solving this quadratic equation using the completing the square technique. This was from an AOPS Algebra 1 homework problem. Alright.